As Rob said, my name is Julian, and well, I know there has been a lot of questions regarding using the FLINT for RED Plus purposes, and I know there is plenty of people on that. And today we'll be presenting some examples of how we are adapting the GCVM model for using it for RED Plus in Chile. We are developing a pilot project right now in one of the regions of Chile, and I will be presenting the progress to date on this project. I was a former MRV professional in Chile, so I know the data and the problems we all have. And nowadays I work as a consultant, and I'm also working with Moja Global, basically mostly on documentation, trying to make things a little bit easier for new users by showing a little bit of this work. So, okay, a little bit of outline. We're presenting a little bit of context on RED Plus in Chile, the methods and data, quickly through the results, but I will focus, of course, on what we learned. What did we learn on this project? So a little bit of introduction. Nowadays, Chile is reporting on the center-south of Chile for RED Plus. That's 5 regions where 41% of the native forest is. We pick these regions because those are the regions where we have more data. So you don't need to start from the whole country. We didn't have a lot of data on the south because of cloud cover, for example. So we just started with these 5 regions. And we already submitted a forest reference emission level, FREL, from now onwards, and a RED Plus annex. Already submitted and approved. We are reporting on 4 activities. That's deforestation, degradation, enhancement, and conservation. So we are not reporting on forest management because we don't have that data. We had a lot of success on the last years. We received result-based payment under the Green Climate Fund. That's $63 million that are being implemented on the territory right now. So given this background, we still needed to improve our MRV system. One of the options that we are seeing is, as already Verne explained, is the generic carbon budget model. That is one of the models that is running on the FLINT platform. And the big deal here with this model is that it reproduces science that is already proven. There is a mountain of papers that you can see about this. So that's really helpful. It's a model that can seem complicated, but there is so much documentation that you can really start digging into it and understanding it. And of course, the amount of science behind it is really useful politically. So you can say, hey, I'm not inventing anything from scratch. So, and one of the other things that is really important about this model, well, also the FLINT, is that the simulations are conducted at a pixel level, sort of, using square tiles. So basically, you are not putting the whole thing into the computer at the same time. So you don't need a huge computer or a workstation to work on it. Like on my personal level, I am running all the simulations on a gaming laptop, and it works. It's not the fastest, but it doesn't crash because you never deplete the RAM completely. You can do it, of course, but you have to make some efforts for that. Why do we want to use the GCVM? Because as I already said, we already have an MRV system in place. But nowadays the calculations are made on Excel spreadsheets, and we all know what the problems are. I don't have to tell you that. It's prone to human errors. You sometimes lack a clear workflow on input and output, and you have limitations on the number of rows. Like, for example, here I just stumbled upon this kind of super long equations that you can have on Excel. At the beginning, it's going to seem easy to use, but when you start getting complexity, things start getting messy. And let's be honest, no one understands this. Not even the person that wrote it can understand it. We know it works. We know the results are good, but try to change something on it. You need something that you can change quickly, that you can really understand. So the work that was performed to elaborate the FREL was also made by 3 different consultants, and they sometimes use different assumptions or emission factors. So that's also a problem. And Chile has plenty of spatially explicit data, but nowadays we are getting all this data and putting it into Excel. So we are losing all this rich information that there is a lot of effort put into this. And we don't want to waste it, of course. So also we need a spatially explicit MRV because we need to report at a local level. We need a more detailed benefit sharing scheme to put this money where it's really needed. We need to do localized policymaking. We need to nest with private projects. Nowadays, we are just subtracting what the private project is saying for some project proposals. But of course, we know that's not ideal. The idea is to have this private project along with the national reporting. And of course, that's something that was required to us for the technical analysis of the FREL and the RED Plus technical annex. So what do? We chose a pilot region in southern Chile. As you can see on the map, it's a small region. It's still twice the size of Jamaica or something like that, half the size of Belgium. So it's not that small anyway. And the first objective was to recreate or try to see where the differences are between our results and the results that the GCBM was providing. That's useful because you can really see where the differences are and what are the improvements you can make. So we started with a workshop on Chile on the Canadian budget model. Then we did some internal work at CONAF, that's the National Forestry organization in Chile, national organization, where we made the initial configuration and land use change emissions. We published a report that is online with the consolidation of the report of the work. We published the source, the code on GitHub. I will put some links later. Nowadays we are working with Canadian funds on implementing more activities for remaining forests, calibrating the model and expanding it to other regions. So a little bit on the methods. As I said to you, Chile nowadays has a little bit of history on land use maps. That's called the National Forest Cadastre, that it was made using manual interpretation and remote sensing, the new ones. And we have a National Forest Inventory. It's not annual, it's also a 10-year cycle as in Canada. So you don't need annually. You don't need it annually. We use that for emission factors and for interpolating some data that I will show you. And this is important. We yet have the land use maps organized in a single file that is harmonized, containing the recorded land use for 4 different years in Los Rios region. In different regions, it's different, or you have different years or stuff like that. But the data is a little bit organized. It's not the best data possible, but it's the data that we had. If your country has history on that or has some work that was already done, it's worth using the data. You don't have to reinvent the wheel. So we need some initial setup and assumptions. We use local temperature data that we got from our research center here in Chile. We created an inventory layer that was super simple. We just set the age of the initial forest fixed, because we use a fixed regional volume data in the FREL. So we only included native forest. That's a heavy assumptions because we just consider forest plantations or non-forest. And now Werner doesn't like that, but that's for RED Plus accounting purposes. What I'm trying to say here is that we had some assumptions and we could use the model to put those assumptions into place, because in a way, you make the data you put into the model is what the model will do, basically. We're using a spatial resolution of 30 meters. And as I'm telling you, I'm running this on a laptop. So we put some custom Chilean variables. I will not go much more into detail, but we used local research for getting, for example, the volume to biomass factors, the stem bar branches and foliage biomass, using some custom Python code. We developed the growth curves using 3 classifiers. That's forest type, structure, and origin. Origin is just this last one. The origin is just a classifier that we are using to see, to for reporting, basically. Like, for example, the origin of the forest is a new forest that was planted during the freeze period, so we can use that for getting different report tables. You can also put classifiers, for example, for the region, or for a special place that you want, or for conservation places, etc. We constructed the growth curves using data from the National Forest Inventory, but really simple in this case, using the same assumptions that we had on the FREL. We had land use change activities. As I tell you, we have land use maps for 4 different years. And in the FREL, in our national reporting, the disturbance areas are interpolated on the 2001 and 2013 period. In this case, the GCVM asks you somehow to get annual data. So we just randomize the disturbance year for each polygon for different periods, and it works. It works, of course, with some differences from a linear interpolation, but the results are quite similar. So you get a polygon, you randomize the year in which it was disturbed based on when the polygon was detected as a disturbance, for example, deforestation. So we have different layers for deforestation, substitution, and new forest, afforestation. We got this data. We create different layers for each kind of disturbance. All the pre-processing codes are in GitHub. I will put the link later. And we are doing this using R, but it can be done using either GIS, even a common GIS program, or Python, etc. We created custom disturbance matrices. There are some disturbance matrices that are already on the GCDM for the Canadian case, but they are easily configurable. For example, in this case, all the biomass in our case goes straight to CO2 when the deforestation occurs. I know that's over the top or is a little bit extreme, but that's the assumption that we made for the FREL. So what I'm trying to tell you here is that you can, again, put that assumption into the GCVM and say, okay, yeah, I'm going to use the same assumption. Let's see how that goes. Same with afforestation. This is something, a question that has been recurrent in the chat, I think. In Chile, for the remaining forest activities, we are using a stock change approach. We're basically interpolating with Landsat and the National Forest Inventory data, all the carbon in 2001 and 2010, and putting the difference there. So in the case of the GCVM, it's gain-loss approach, as Werner said. So basically, we have this degradation and enhancement identifiers that I'm not going to go into detail, and we have this carbon change between the two dates. As you can see on the bottom image, there's an infinite number of combinations in a 1 hectare resolution pixel. So we adapted it by just dividing the carbon loss, the percentage of carbon loss between 20 different degradation intensities. You can make 100 if you want, but it doesn't make much of a difference. We just say, like, for example, this pixel lost 20% of the carbon according to the stock change approach. So we put it on the, for example, on the, how do you say it, on the degradation intensity 13 or 12, it will be according to that table. So basically, we constructed 20 disturbance matrices. Like, for example, it went from this source, from this pool to this other pool, and the percentage of transfer between pools according to the stock change approach. And it works quite well, actually. The year of the degradation, in this case, was also randomized. The case of enhancement, we did more or less the same, just changing the growth curves, assigning a higher growth in between pixels, and again in 20 enhancement intensities. So we constructed new growth curves. A little bit on the results. I will go quickly into this because local, maybe you don't need that much of the detail, but it's everything on the report. So nowadays we are modeling all the activities with spatial explicit data. That's everything but non-CO2 emissions from forest fires, where we just have tables, but that's really a small percentage of the emissions, because in our stock difference approach, we are getting the CO2 emissions from forest fires. The randomization of the years, of course, creates a little bit of unbalanced data, because we are randomizing each polygon, so that's important. So that will create a little bit of a difference between the FREL, the current report, and the GCVM. As I tell you, as when we start seeing the results, we see small differences in biomass emissions, due mainly to randomization of the disturbance years and the value of post-disturbance biomass that is considered in Chile, and big differences in DOM emissions, and that's because the methodologies are totally different. In the GCVM, the DOM is simulated based on several parameters, turnover parameters that we left as default. We're just using the temperature data from Chile. And Chile uses data from sampling from the National Forest Inventory, and just Los Rios region specifically has a really high DOM value, DOM value. So that's the biggest difference that we have between the two methodologies right now. In afforestation, we have much better results. Again, due to randomization, we have a little bit more of removals in this case, and again, pre-afforestation values. In degradation, we have this 11% difference, and this is a really interesting result, because it shows us the difference between having separate spreadsheets for each of the activities, for example, and I know people do that because it's different data. Okay, let's put it in different spreadsheet, but when you start to integrate everything, things start getting messy, and you start seeing not something that was badly calculated, but when you integrate it, you get different results. For example, in this case, the map that is on green and brown is the land use map that is much more detailed than the map we use for measuring degradation, this stock difference approach. So for example, in this case, in the Excel spreadsheets, we just get the raster data and we put it on a spreadsheet and we calculate that. But when you start integrating everything into the GCVM, you see that, for example, degradation is occurring in places where you effectively don't have forests, especially in the center part of Chile where forest is really scattered and fragmented. So that's something that we started seeing right away, and we could explain the difference, and that's really important. In the case of enhancement, the differences are really small, 2%, again, due to the integrated approach on the GCVM. In terms of forest conservation, the differences were even smaller, less than 1%. We are getting the same results. We had the same assumptions. We had the same data, same results. And when we get the whole picture, we are having less emissions on the GCVM. That's 30% less emissions, roughly 200,000 CO2 tons per year. But when you start seeing each of the sub-activities where we have more differences are in deforestation and substitution, and that's where we are counting the dead organic matter, where the methodology is totally different. But what we're trying to prove here is that you can put the same assumptions into the same data and get coherent results, and get results that you can explain the difference why, and maybe that can lead to improvement, and that's the next steps. And this is the important part. We are just reporting on how do you say it, on tabular data, on tables, but now we can get especially explicit results. We can see the delta total biomass in different years, see where it is occurring, where hotspots, etc. You can see it, year by year. I don't know if you can see the animation, but it's not really funny because the deforestation in Chile is really small patches that you can see. But you can see it year by year, at least with this randomization. And this is also really important. You can get several different indicators from the GCVM, and they really help you see sometimes errors, or not errors, but opportunities of improvement on the data. You can see, hey, why am I getting these really high above ground biomass values? Because sometimes when you put everything on a table, you stop seeing some issues that you can be having with the data, and the GCVM really helps you with that, because these are 6 indicators, but there are 1,000, and you can create your own. You can see, for example, where are the emissions occurring, and you can separate it by DOM emissions or biomass emissions. See the above ground biomass carbon, that really helps you to debug a little bit of the model, to see, for example, if your volume to biomass equations are working, etc. So this is also really helpful. What did we learn? We learned a lot of stuff. As Werner and Robert were saying, there are some conditions for a cost-effective implementation. This pilot project was done in little time, with a few professionals only, and a lot of it was started locally with the same people we were working on the MRV team. Why it was cost effective? Because the spatially explicit data was already available and consolidated, and of course I know that's not the case for other countries. Most of the work has to be done to produce high quality data and consolidate it. And this is important. The setup was performed by local professionals with knowledge of the data and the assumptions. So there was a lot of theory work that didn't have to be done, and that's important. And that really puts the cost down. The initial implementation of the GCVM requires 1 or 2 professionals with both Python SQL skills, that's basic programming skills, and of course, but most importantly, knowledge of the data and assumptions. The GCVM can be successfully adapted to reflect local assumptions and data. And again, sorry for repeating myself, but really important is to be able to explain the differences between the 2 approaches, and because there you can get the improvement. And for that, the amount of papers, user manuals, and help from the Canadian Forest Service is really important, and you can explain most of it. Also, the output tables and the output indicators really help, because there is so much information to be used. So, importantly, it can provide spatially explicit results. You can test different assumptions and a scenario, not modifying these really messy Excel spreadsheets, ensuring carbon balance and an integrated approach. And that's really important also, to see the coherence of your model. And of course, it can lead to a better understanding of the dynamics of the forest. It will produce, if you have a methodology in place, it will produce differences. There's nothing to do about it. The important part is that you can explain them. The collaboration between the local MRV team that we are always in communication with, professional with the Canadian Forest Service, that has been really helpful, especially in the beginning when you are like struggling with the model. And the Moja global community was key on the implementation of the GCVM, and we are nowadays putting work hours into the documenting the work, especially on the Moja global GitHub repos, where you can find more information. And well, that's the second point. They already said it is a more sophisticated platform, has the potential to improve your analytical power, see different assumptions, report several times, because let's be honest, you take a stone from the ground and you see another organization that is asking you to make a report. That's a mess, and you need a model that can deal with that, that can quickly get new results with new assumptions, new data. A little bit of the difficulties, as I said, you need someone that can do some basic coding. A lot of help is being provided by Moja Global and the Canadian Forest Service in this case, but you still need a little bit. You need someone that can code a little bit on Python and can understand JSON or SQL. But most of the heavy machinery of FLINT or the heavy machinery of the GCVM is already fixed. You don't have to mess with C++, for example, or like heavy programming languages. I'm not a programmer, and I could do it. Sometimes this is really specific, but the volume to biomass factors functions were difficult to adapt because there is a format that the Canadian team uses, but it can be adapted. And of course, we had some problems with the non-forest stands that are used to get the emissions from deforestation, for example. And one possible solution is to integrate it better with FLINT, because this is just a model. We can integrate it with other models. At the beginning, there was a lack of technical documentation on a user manual when we started, but now there's much more. There are even YouTube videos that you can see that were not existent at the moment. So now everything is getting easier, but at the moment it was complicated. Next steps, we need to calibrate the DOM emissions using national knowledge, expand the pilot to other regions of the city. That's something we are working on. Consolidate the pilot project report. At the end of the year, we hope to have another report with all the steps that we made to get this pilot project, and a lot of the details on the differences or what we had to do. And in the medium long term, of course, we have to include updated data and forest on land use change and forest remaining forest that is being developed now, new assumptions. And we also have to move away from the frail and start designing improvements. And that's something, because nowadays we simplified the GCVM a little to make it fit with the Chilean data that we were already using, but there is a lot of data that can be included into the GCVM that we are not using nowadays because it was a pilot project, but the idea is to start improving the model, include other reporting periods, calculate the uncertainty that we know that's really difficult, and of course include the GCVM FLINT on Chile's reporting. That's something that has to be discussed with the MRV team, but these results are really encouraging in a way that we know how the GCVM is working and we know how what are the differences that we can expect between one and the other, and that's really important in a political point of view. If you want to present this to the policymaker or your boss, that sometimes will ask you, like, what's the big difference? What can we expect? Well, thank you very much for your attention. That's my name, my email. The implementation repo where the standalone GCVM implementation was conducted with all the custom stuff we had to do for Chile. The data preprocessing repo that was performed on our language. I know some people, especially in Latin America, use that language to handle data, and we are working on the documentation for that. A lot of improvement has been made, and the link for the technical report that is nowadays on ResearchGate. That's not the whole work because we are working on it right now, but it can be a good start especially for land use change emissions. Oh, thank you very much. Sorry if I went a little bit long.